Hello students, I hope you all are doing good and preparing well for KCET exam. Okay, so in today's session, we'll be solving previous year questions that were asked from inverse trigonometry chapter. Okay, so this chapter has got a weightage of about 2 to 3 marks and it is a very scoring topic. Okay, don't leave this topic. Very simple questions were asked from this chapter. And I would suggest you to pause the video and try to solve the questions on your own, and only after that look at the solution part. Okay, uh, moving on to the questions. Okay, so what have we got? The range of sec inverse of x is, this was asked in 2017. Okay, so sec inverse of x. Okay, this is a simple question, direct. This is actually a memory based question. With based on memory you should directly tick, but I'll just explain you. So sec, how is the sec graph? It is like this, right? And this is our principal value for our inverse trigonometric function. So as you can see, it is between 0 to pi, and at pi by 2 it is not defined, right? So the domain, the range of this function, the range of this inverse trigonometric function, I have, this is the graph of sec x. Okay, okay, using sec x I am telling you for sec inverse of x. So as you can see, it is from 0 to pi, and pi by 2 is not there. This we have to uh, remove. So the correct answer is option B. So option A is wrong. Okay, if in hurry, if you take option A, you lose the mark. Okay, so remember this pi by 2 is not there. Okay, because here it is not defined. Okay, so the range of sec inverse of x is 0 to pi minus pi by 2. So I would suggest you to remember all the domains and range of all the trigonometric functions, all the inverse trigonometric functions. You can find this in your textbook. Okay, very easily you can find them in your textbook. Moving on, you can expect a question from here. Okay, moving on, what do we have? Okay, we have got this question. Okay, interesting question. So let me just write down alpha 2 sine inverse of x plus cos inverse of x less than or equal to beta. So I can write 2 sine inverse of x as sine inverse of x plus sine inverse of x. Agree? Okay. Plus cos inverse of x less than or equal to beta. What does this tell me? Sine inverse of x plus cos inverse of x, the standard result, it is equal to pi by 2. Sine inverse of x plus pi by 2. Okay. So next what I would be doing is I would be subtracting pi by 2 from the entire thing. What do I get? Alpha minus pi by 2 sine inverse of x less than or equal to beta minus pi by 2. Okay. So tell me what is the range of sine inverse of x? It is between minus pi by 2 to plus pi by 2, right? Everyone agrees? Okay. This is the standard thing that we know. This is the range of sine inverse of x. Okay. So comparing these two, I have to compare these two. What do I get? Alpha minus pi by 2 equal to minus pi by 2. That means alpha is equal to 0, and comparing this with this, what do I get? Beta minus pi by 2 is equal to pi by 2. This implies beta is equal to pi by pi, right? Pi by 2 will go this side, pi by 2 plus pi by 2 is pi. So 0 comma 0 and 2 pi, 0 and pi. So the correct answer is option D. So this is how you solve these type of question. So again, yeah, as you can see, you need to know the principal range of sine inverse of x. The range of sine inverse of x is minus pi by 2 to plus pi by 2. So I would suggest you again to memorize the domain, principal domain and the principal range of all the trigonometric functions, all the inverse trigonometric functions. Moving on. Okay, so this is a similar question that was asked. This is a similar to what we did in our previous question. Instead of sine and cos, they have given us 2 tan inverse of x plus 3 cot inverse of x. So here I'll give you a hint to solve this. So we need to use this property, tan inverse of x plus cot inverse of x equal to pi by 2, and we need to know the range of cot inverse of x. What is the range of cot inverse of x? It is 0 to pi. Okay, using this to, you can solve this question. Wait a second, cot, what is the graph of cot? So it is 0 to pi, sorry, I'm so sorry, it is not equal. So using this you need to solve. Using these two, you can solve this on your own, and in the comments you can tell me the answer. I'll check that and let you know. Okay, try this question. Okay, moving on. uh, Again, this is a good question. So what have I got? If tan inverse of x plus tan inverse of y equal to 4 pi by 5, then cot inverse of x plus cot inverse of y is equal to, okay, let me just write that down, tan inverse of x plus tan inverse of y equal to 4 pi by 5. I can write tan inverse of x as pi by 2 minus cot inverse of x using the standard result. Agree? Similarly, tan inverse of y, I can write that as pi by 2 minus cot inverse of y. Right? Now on simplifying, pi minus 4 pi by 5 is equal to, I'll take this cot inverse of x and cot inverse of y to my right hand side. So what do I get? What is pi minus 4 pi by 5? Pi by 5, right? Simple question. So the correct answer is option A. This can be easily solved in a minute. Okay. Moving on. Again, a similar question. Sine inverse of x plus cos inverse of y equal to 2 pi by 5. Let me write that down. Sine inverse of x plus cos inverse of y is equal to 2 pi by 5. Okay. So I can write sine inverse of x as pi by 2 minus cos inverse of x. Agree. Cos inverse of y can be written as pi by 2 minus sine inverse of y, 2 pi by 5. Now I'll take these two to my RHS. So I'll get pi minus 2 pi by 5 cos inverse of x plus sine inverse of y, which is the required thing. So this is nothing but 3 pi by 5. So the correct answer is option B. So this was similar to what we did in the previous question. Okay. Moving on. Okay, this is a slightly good question. This is a good question. If sine inverse of x plus sine inverse of y is equal to pi by 2, then x square is equal to. Okay. Let's just solve this question. Sine inverse of x plus sine inverse of y is equal to pi by 2. So what simplification I can do? See, I can write this as sine inverse of x pi by 2 minus sine inverse of y. Everyone agrees? Now see, pi by 2 minus sine inverse of y is nothing but cos inverse of y, right? So see what is happening here. If I equate this to theta, I get two equations, x equal to sine theta and y equal to cos theta, right? So we are asked what is x square. Using this data, I can write sine theta as 1 root of 1 minus cos square theta. Everyone agrees using this information. So substituting the value of cos, that is y square. So sine theta is equal to 1 minus y square theta, root of 1 minus y square theta. But what is sine theta? From this I can write it as x. Now tell me what is x square? 1 minus y square. Okay, so the correct answer is option A. So yeah, this will come with lot of practice. Okay, if you practice more, you will try to find this kind of patterns and logic building will happen. So what we did here, first we took this to our RHS and we simplified this. This is nothing but we applied the standard property, then we equated this to theta. So using this, cos inverse of y equal to theta means y is equal to cos theta. Similarly, x is equal to sine theta. Using y equal to cos theta, we found out what is sine theta. That is nothing but root of 1 minus cos square theta. And we simplified, and that is how we arrived at our solution. Okay. You need to practice more. Okay. Moving on. Okay. Again, a similar question. So see, using on that property, you can expect at least a single question, most probably. Okay. So let us apply the property here. I am writing 3 tan inverse of x as 2 tan inverse of x plus tan inverse of x. This is nothing but 3 tan inverse of x only. Everyone agrees, right? So this is equal to pi. So what is this? Pi by 2, right? 2 tan inverse of x. I am directly taking this to my RHS. Pi minus pi by 2. This is nothing but again pi by 2. So my tan inverse of x is equal to pi by 4. What value of angle is for what tan? This is nothing but, okay, let us make this. I can write this as tan of pi by 4 equal to x. Agrees? So what is my x now? 1. Simple. This was a simple question. Okay. Simple properties we need to apply and solve. Moving on. Okay. What have we got? Sine inverse of 2 root 2 by 3 plus sine inverse of 1 by 3 is equal to. Okay. When you see these kind of questions, you should see what property I can apply. Okay. Here I think I can apply this property. Sine inverse of x plus cos inverse of x equal to pi by 2. To apply this property, I need cos inverse. So somehow if I can change this in terms of cos inverse, I can apply this property, right? So let me see how I can do that. I'm just taking sine inverse of 1 by 3. Let me call it theta. Okay. Now sine theta is equal to 1 by 3. What is cos theta? Cos theta is nothing but 1 minus sine square theta. Square root of 1 minus sine square theta. Sine theta, sine square theta 1 by 1 minus 9. So this is nothing but 2 root 2 by 3. So cos theta I have got as 2 root 2 by 3. From this I can write theta is equal to cos inverse of 2 root 2 by 2 root 3. Sorry, this is 2 root 2, no? I am so sorry. 2 root 2 by 3, right? So here, so coming back to our question, it is nothing but sine inverse of 2 root 2 by 3 plus sine inverse of 1 by 3. Okay. Sine inverse of 2 root 2 by 3. Sine inverse of 1 by 3 is nothing but theta. Okay. Again, in the next step, I can replace theta with cos inverse of 2 root 2 by 3, right? Sine inverse of 2 root 2 by 3. Now tell me, I can apply my standard formula. It is pi by 2. Simple, right? So I have done it step by step. So this might look to you lengthy, but it is a very easy question. Okay. So you just need to look at the question, simplify it, how you can bring it to the standard form and apply the standard results. That's it. Okay. Moving on. Okay. The value of sine inverse of cos 53 pi by 5. So you can find this question in your exemplar book. This is a direct, like they have copied the question from exemplar. Okay, so I would suggest you to solve all the questions of exemplar book. You can expect around 10 questions that will be same exact questions. You can just blindly take the option. If you remember, you can directly take. So don't forget to solve the exemplar book. Okay, this is a must. Okay, moving on. So we have got sine inverse of cos 53 pi by 5. So here our idea should be how I can change this cos to sine. Okay, how I can do that. Okay, let's focus on that. Cos of 53 pi by 5. I can write this as cos of 50 pi plus 3 pi by 5. This can be written as cos of 10 pi by 3 pi by 5. Now I can write this as cos of 3 pi by 5. But as you can see, 3 pi by 5 is not an acute angle. So again what I'll do, pi minus 2 pi by 5 is 3 pi by 5. You can find this. Pi minus 2 pi by 5 is nothing but 3 pi by 5. So now what is cos of pi minus 2 pi by 5? Minus of cos 2 pi by 5, right? Because we are in the second quadrant. Now I can write minus cos 2 pi by 5 as cos of pi by 2 minus pi by 10. Okay, you can check that out. Okay, somehow I want to represent it in terms of pi by 2. If you solve this, you will get this pi by 10. Okay, so pi by 2 minus pi by 10. If you solve this, you will get 8 pi by 10, which is nothing but 2 pi by 5. So minus cos pi by 2 minus is nothing but minus sine pi by 10. Now I'll substitute this back in our question. Okay, sine inverse of cos of 2 pi 53 pi by 5. So cos of 53 pi by 5, we have reduced it down to, in terms of sine, as minus sine of pi by 10. Okay, sine inverse of minus is something of minus is minus only. So okay, we know that property. Sine of pi by 10. So now tell me, what is minus, what is this? This is nothing but pi by 10, right? Agreed? This is minus pi by 10. So here you need to know the knowledge of trigonometry. Okay, using trigonometry we reduce this angle and we brought it, we expressed, what we did was we expressed cos 53 pi by 5 in terms of sine, and we simplified it. That's it. Okay, simple. This was a multi concept question. You need to know the concepts of trigonometry as well. Moving on. Okay. Before I start this question, I would want to tell you that I have created a YouTube playlist called KCET 2023. You can check that out in my channel. So there you can find videos of chapter wise PYQ question. I have covered almost entire 12th standard. One or two chapters are left. You can expect videos for that in the coming days. Okay, so you can refer that playlist. I would suggest you to try and solve the questions on your own, and only after that look at the solution on my video. Okay. Okay, coming back to the question, what we have got, tan inverse of x by y minus tan inverse of x minus y by x plus y. Okay, so here nothing. We have to just apply the standard result, tan inverse of a minus tan inverse of b. What is this? This is a standard result. Tan inverse of a minus b by 1 plus ab. So a minus b is x minus y by x plus y. Here 1 plus AB, right? I am applying the standard result. You can refer the textbook. Okay. So what do I get? Tan inverse of x square plus xy minus xy plus y square. Similarly here, what do I get? Xy plus y square plus x square minus xy. So as you can see, I'll get tan inverse of 1. What is tan inverse of 1? It is pi by 4. Simple question. Correct answer is option B. So we directly applied this property. So this is also, you can expect a question similar to this on applying this property, tan inverse of A plus tan inverse of B, or tan inverse of A minus tan inverse of B. Moving on. Okay. So this question looks difficult, but it is easy question. Okay. Okay, let me just write that down. X plus 1 whole square, x cube plus x equal to A by x plus bx plus c. So this question was asked in 2015. So I myself have also given 2015 KCET. Okay. So this question I have attempted in my real exam. Okay. I don't know whether I have solved this or I have not. I don't remember. Okay. So x plus 1 whole square. Okay. Let's simplify this. Okay. On simplifying, I get a x square plus 1 plus bx plus c x. Okay. A x square plus a plus bx square plus cx. Okay, so here it is nothing but a plus b x square plus cx plus a. So all we have to do is we have to compare the coefficients and solve. So as you can see, the constant term 1 and a. So a is equal to 1, a plus b is equal to 1. That means b is equal to 0, and c is equal to 2. Okay, we have got this. We just need to substitute now. Cosec inverse of 1 by a plus cot inverse of 1 by b plus sec inverse of c. So a is 1, right? Cosec inverse of 1 plus cot inverse of infinity plus sec inverse of 2. Cosec inverse of 1 is nothing but pi by 2. Cot inverse of plus infinity is 0. Plus sec inverse of 2 can be written as cos inverse of 1 by 2. What is cos inverse of 1 by 2? Tell me. It is nothing but cos 60 is 1 by 2, right? So it is pi by 3. On simplifying, I get 5 pi by 6. Okay, slightly lengthy question. This might take you maybe 2 minutes. Easily, this will take 2 minutes. But other questions which might take only 10 or 15 seconds, you can compensate the time there. Okay, but this is an easy question. Okay, simple question, simplification question, slightly lengthy. Okay, so this is a good question. Okay, here you need to use your observation skills and look at the question. Okay, tan inverse of 1 minus x by 1 plus x equal to 1 by 2 tan inverse of x. Okay, so looking at 1 minus x by 1 plus x, I'm getting some hint. I can write this as tan 45 minus tan theta 1 plus tan 45 tan theta, right? I can write this, right? Everyone agrees? One second. Yeah, I can write. If I take x is equal to tan theta, I can write this, right? I can write 1 minus x by 1 plus x as like this in terms of tan 45. So what is this? This is nothing but tan of 45 minus theta. Agreed? So this I can replace, right? Tan inverse of 1 minus x by 1 plus x can be replaced as tan inverse of tan of 45 minus theta, which is nothing but pi by 4 minus theta. 45 in radians I have written pi by 4 minus theta. This is equal to, so see, we have taken x equal to tan theta. This implies theta is equal to tan inverse of x. So half of tan inverse of x is nothing but half of theta. And simplifying this, what do I get? Pi by 4. Pi by 4 equal to 3 by 2 theta. 2 2s are 4. Pi by 6. So theta is equal to pi by 6 I have got. So they are asking us what is the value of x. X is equal to tan theta, right? And I know what is the value of tan 30. Pi by 6 is tan 30. Tan 30 is 1 by root 3. So the correct answer is option B. So yeah, this is observation, right? You need to use your trigonometry knowledge. Looking at this, see how should be the thought process. So when you look at something tan inverse of 1 minus x by 1 plus x, try ki how you can represent 1 minus x by 1 plus x in terms of tan. If you can do that, see if here we represented it in terms of tan, you can cancel this. Tan inverse tan gets cancelled and only we are left with 45 minus theta. That was the first hint that we get. So when we want to express 1 minus x by 1 plus x in terms of tan, so looking at 1, you should get an idea that, okay, I can represent that as tan 45. So that is how you build the logic. Okay. So this comes with practice and observation. Okay. This is a multi-concept question. So you need to revise your trigonometry knowledge. Okay. It is important. Moving on. Okay. Another good question. Directly, the value of the expression. So these type of questions have got a standard method to solve. Okay. They are asking us tan of 1 by 2 cos inverse of 2 by root 5. So what I'll do is cos inverse of 2 by root 5 as theta. Okay, I'll take it as theta. So I'll get cos theta is equal to 2 by root 5. So if I substitute theta, what I am getting? Tan of theta by 2. This is what I have to solve. Okay. So we have to think how I can relate these two, cos theta and tan theta by 2. There is a standard result for this. Okay. It is 1 minus cos theta by 1 plus cos theta. You can simplify this and check, you will get the same thing. 1 minus cos theta is nothing but 2 sin square theta by 2. 1 plus cos theta is nothing but 2 cos square theta by 2. Cancel square root, again we get tan theta by 2. So this is a result that you need to remember. Okay. So this is how, looking at cos theta and tan theta by 2, you should in your mind you should get this result. Now all you have to do is you have to just substitute the value of cos theta. 1 minus 2 by root 5, 1 plus 2 by root 5. This is nothing but 1 root 5 minus 2 by root 5 plus 2. I have to rationalize, okay, because rationalizing, what do I get? Rationalizing meaning root 5 minus 2, root 5 minus 2. This is nothing but in numerator I am left with root 5 minus 2 because this gets squared, and in the denominator I get 5 minus 4, that is 1. So the correct answer is B. Okay, this is a slightly difficult question, but with practice it will come. So revise the formulae of trigonometry. Okay, very important. Moving on, another simple question. Let me see what have we got. Cos of 2 sine inverse of 3 by 4 plus cos inverse of 3 by 4. Okay, cos of 2 sine inverse of 3 by 4 plus cos inverse of 3 by 4. Okay, so see, I can split 2 sine inverse of 3 by 4 as sine inverse of 3 by 4 plus sine inverse of 3 by 4. Agreed? No issues. I am doing this step by step, okay, but with you can do this directly in your exam. No need to do all the steps. This is nothing but pi by 2 cos of pi by 2 plus sine inverse of 3 by 4. So in the second quadrant, cos is negative. minus cos of minus sine of 3 by 4, because it is pi by 2, right? Cos of pi by 2 plus theta is nothing but minus sine theta. Same thing I have done. Sine gets cancelled, minus 3 by 4. So the correct answer is A. Okay. It is important, right? This minus is important. If you miss the minus, everything is gone. Because cos is negative, right? Cos in second quadrant is negative. Okay. Moving on. Okay. The domain of the function defined by f of x equal to cos inverse of root 2x minus 1. Okay. So they are asking us, what is the domain of simple cos inverse of x? Tell me. Domain is nothing but what values x can take. So x can take values from 0 to pi. Sorry. From minus 1 to plus 1, no? That is the range. Domain, x can take values from minus 1 to 1. Everyone agrees? Okay. So they are asking us from root x minus 1. Same thing we have to do. Root of x minus 1 less than or equal to 1 minus 1. Okay. So let's concentrate only on this. When I do that, I get x minus 1 is less than or equal to 1, x less than or equal to 2. So upper bound we have got. What about the lower bound? Okay, so root of x minus 1 is greater than minus 1. It cannot be negative. So for this condition, what I will do, we took here only this condition. For this condition, see, look at this condition. So this quantity will always be positive. That means I can replace minus 1 with 0. Okay, because it is never going to be negative, right? So this is nothing but greater than or equal to x minus 1. Now squaring on both sides, I get x minus 1, x1. So as you can see, x is greater than 1, but x is less than 2. That means it is greater than 1, combining both the conditions. Both the conditions I have combined. X is greater than 1 and x is less than 2. Okay. So the correct answer is 1, 2. So this is how you solve the questions. So again, you need to know the principal domain and principal range. This is very important. If you don't know this, you cannot solve. So I am again telling you, repeating you to memorize it. Okay. Okay. So the value of cos of sine inverse of pi by 3 plus cos inverse of pi by 3. Very easy question. Okay. What you have to do? You have to just apply the property, right? Tell me, what is this? Sine inverse of pi by 3 plus cos inverse of pi by 3. What is it? Directly, cos is, we know the property, right? No need to solve it. It is nothing but pi by 2. Pi by 2. Right? It is pi by 2. Cos of pi by 2 is 0. Cos 90 is 0, right? Option A. So, uh, using the property we have done, sine inverse of x plus cos inverse of x is equal to pi by 2. Using the property we solved. Okay, so this was the last question. So I hope this session was helpful to you, and if this session was helpful to you, please like the video. You can share this video with your friends also, and please subscribe. If you can subscribe to my channel so that you don't miss any of my videos. And I have covered all the chapters, maximum chapters I have covered. You can check out the playlist called KCET 2023. There you can find chapter wise previous year questions solved. I have also attached the PDF of this PPT in the comment section. In the pinned comment, you can find the PDF of the PPT. There you can go and solve the question. Okay, and check. If you are not able to find the solution, you can come back to my video and check out the solution. So this way you will be, these are previous year asked questions. Okay, so you will become more confident for the exam. Okay, so yeah, that's all for today's session. Thank you.